Hi guys, sorry I forgot to post it yesterday. Anyway, so now we're getting into antiderivatives and integration. So we're actually going to be doing the opposite. So taking the antiderivative or integrating a function is doing the opposite of taking the derivative. Also remember, again, you can pause this whenever because I'm just going to keep on going through it. So pause at certain points to write things down or whatever you need to do. So the definition, a function f is an antiderivative. So notice the f here is big, so it's the antiderivative of f. So we're saying that f prime of x, so big F equals f of x for all x and I, where I is the interval. 2, if f is an antiderivative of f on an interval I, then g is the antiderivative of f on an interval I, if and only if g is of the form g of x equals f of x plus c for all x and I, where c is a constant. I know that's a lot of words and it's probably kind of confusing. We're, like always, we will be doing examples and things to work through it to see what exactly I mean by that. So notation. This symbol right here is really important. That's our integration symbol. So whenever you see that, that means you are integrating or taking the antiderivative. Okay? This is the integrand. So what we are taking the antiderivative of, what we are integrating. This is our variable of integration. It will be incorrect if you do not have dx at the end. It's incorrect if you don't have dx or dt, whatever your variable is, attached at the end. Then when you take the integration, one moment. Okay, sorry about that. Okay, I don't know where I went, but the constant of integration is right here. And so that just means you have to account for that there could be a constant. Because think about if we are doing the opposite of differentiating, if you took the derivative of y equals 2x plus 4, the derivative of that is 2. So we have to account for that constant going back the other way. So, anyways, okay, I'm not sure if you can see me or not, but we're just going to go with it anyways. Finding the general solution of a differential equation. So when you're taking the derivative, that's what you're doing. You're finding a differential equation. So y prime equals 2. So this is actually the example I just said before. Y prime equals 2. What this is saying is whose derivative is 2. So what would the derivative of 2 be? So if you took the derivative of a function and just got 2, we should know that y would equal 2x or 2t, whatever our variable of integration is right here. And again, you have to add this c on, because if you took the derivative, the constant would fall off. It would go to 0. So the derivative of y equals 2x plus c is y prime is 2. Okay? So this is considered an indefinite integral because we have to always attach that constant c to the end. You can check your work by taking the derivative of your result. So again, if the derivative of y equals 2x plus c is y prime equals 2. So we've checked our work. Okay, basic integration rules. You will need to know these. So A, the inverse nature of integration and differentiation can be verified by substituting f prime of x for f of x in the indefinite integration definition to obtain. So this is just saying that this integrating f prime of x gives you f of x. Okay, they are inverses. So, and then again, if you take the derivative of a function and you get that, then, so d dx, remember, is taking the derivative. So these are the equivalent things. So differentiation is the inverse of integration. They work together. The power rule, sorry about that. The power rule says if f of x equals x to the n, this is really actually the most important thing you're going to need to know and be able to use right now. So if f of x equals x to the n, then the integration of f of x is x to the n plus 1, so we're adding 1 to that, over n plus 1. And then again, you have to attach c at the end to account for a constant. The only time this doesn't work is when n equals 1. So that's something you need to know for 100, like we'll use it every time we integrate. And then constant multiple rule is just saying you can pull the constant out front of the integration symbol. You do not have to do that, but you can. And then similar to our natural logs, but not exactly the same because it's not anything with multiplying, but you can break the integration apart at pluses and minuses. So make sure you have these rules written down. If you need to pause it, pause it. Examples. So describe the antiderivatives of 3x. So what is that saying? It's because it says antiderivatives, that should immediately trigger your brain to set up an integral. Okay, so this is what I mean by integral. Notice we have a constant, 3, we have x, and we have dx. How can you rewrite this? What is the same as 3x? What is our exponent up there? Okay, so first of all, we are going to pull our 3 out front, which again, you do not have to do that, but you can. And that's our constant multiple rule. Why did I add that 1? Why did I do that? Well, because that's our exponent. Our exponent is 1. So now we're going to use the power rule, which says to integrate, so to get rid of this symbol, our s, and our dx, we have to do x to the n plus 1, where in this case n is 1, so x to the 1 plus 1, which is x squared, over 1 plus 1, which is 2. So we have, right here, we added 1 to our power, and down here we added to the bottom as well. So, and again, that's our power rule where n equals 1, and then just to write it nicer, 3 over 2 x squared plus c is the antiderivative of 3x. Okay. So another example, what is the antiderivative of f of x over x, 1 over x to the third? So again, we have antiderivatives, so that should immediately tell you you need to set up an integration. So you need to have the little symbol of integration. Right, here we go. Okay, our steps though, we're going to rewrite this. So how can you rewrite 1 over x to the third so it's something easier to work with? So think about when we rewrite for taking derivatives and things like that. Similarly, we're going to rewrite this x to the negative third. X to the negative third. Now we're going to apply the power rule. So in this case, n equals negative 3. If we add 1 to negative 3, we get negative 2, and there's nothing, we don't have a constant or anything, so it's just over negative 2. Power rule where n is negative 3. So negative 3 plus 1 is negative 2, and on the bottom we have negative 2 as well, because it's over n plus 1, and n is negative 3, sorry. So then again, I rewrote it and simplified it so it looks a little bit nicer. Okay, I want you to go ahead and try these problems. I am going to click on in a moment, and then you'll see the answers to them. But so pause it and try these problems on your own. All 4 answers will come up at the same time. So keep in mind for A, your exponent, so if I attached an x here, is just to the 0 power. Here you could break that apart if you wanted to. Here you could break this apart again, and you have 3 different exponents, so you have to integrate each portion. Here I would do some rewriting. In D, I would do some rewriting. And the answers to these are, so the derivative of 1, or I'm sorry, the antiderivative of 1 dx is just x plus c, because we have x to the power of 0 technically, because anything to the 0 power is 1. 0 plus 1 is 1, so x to the 1 over 1 is just x plus c. Remember, you always have to attach c at the end because you're accounting for the constant, and you must have this dx or whatever the variable is. Go ahead and check your work for these, and I will be moving on, so if you need to pause it, that's fine. Okay, these are your classwork problems. They need to be done when you come in on Monday morning. So you need to be completely finished with them when you come to school on Monday morning at 7:15 in my room. Make sure you get them written down and have them done. I am going to check them. It's kind of like your homework. It would be like if I was collecting the classwork in class. I think that's all. Yep. Okay, so I'll put those back up for a second. Sorry about that. And if you have any questions, please email me or message me on Schoology, and have a wonderful weekend.